the most expensive brick on the block.
Tesla shares lower ahead of the company.
Well, there definitely is a slowdown of EV adoption.
GM has recently unveiled their all-new zero-emission engine, which will render electric and internal combustion cars obsolete. This all-new innovative technology is supposed to be the next revolution in the automotive sector, propelling us toward a totally environmentally friendly future of automobiles. So don't waste any time and check out this new way of thinking as GM CEO unveils this revolutionary engine that will transform the car industry. So what's the deal with this brand new technology? Well, GM's been exploring various alternatives to electric vehicles for quite some time, and their search has recently brought them to the innovative compressed air technology. Compressed air has proven to have limited applications in the 19th century, particularly with mine trains and trams in various European cities, with Paris being the most popular one. However, due to internal combustion engines' instant potency, the technology has since been abandoned and forgotten. However, in the early 2010s, the French vehicle maker Peugeot saw the possibility of mixing compressed air with internal combustion engines to create an entirely new hybrid technology that keeps the eco-friendliness of a standard hybrid while eliminating the need for a battery. While these prototypes did not get beyond the testing stage, they caught the curiosity of the rest of the automotive manufacturers, particularly General Motors. GM noticed the potential that compressed air vehicles offer. However, they recognized that this kind of technology would need significant improvement if it were to compete with traditional internal combustion engines and the growth of electric vehicles. As a consequence, GM began quietly exploring and developing compressed air technology in conjunction with the development of EVs and internal combustion cars. Now, you might be thinking, how do compressed air vehicles work? Well, compressed air vehicles operate quite differently from conventional engines and EVs. Instead of a traditional piston-driven engine or an electric motor, compressed air vehicles use specially engineered pneumatic engines, also known as compressed air engines. These engines are mechanically quite similar to conventional internal combustion engines. The engine employs pistons in the same way as gasoline engines do. Unlike combustion engines, a pneumatic motor's pistons are attached to a spring. Instead of depending on an explosion to generate piston motion, pneumatic motors pump air into the chamber, raising the pressure within it and pushing the piston to its full length. The air is then released and the piston is pulled back into its original position by the spring attached to it, completing the cycle. In terms of functionality, the engine is quite similar to internal combustion engines, allowing for a variety of technical solutions, which is what attracted GM to this concept, as it helps to speed up the development process. With that in mind, let's get to the most exciting question. What are the advantages of compressed air vehicles over EVs and gasoline-powered vehicles? The most significant advantage is, of course, that it's completely pollution-free. It's simply compressed air. Thus, it has no negative impact on the environment. As a consequence, compressed air engines address one of the most serious difficulties with traditional combustion engines: direct contamination of the environment. Compressed air engines also outperform EVs in this sense, since they're far less expensive to manufacture and need no rare earth minerals, as opposed to batteries or electric motors. Not to add that charging EVs is not entirely green, since the grid still relies heavily on fossil fuels to generate energy. Another significant advantage of compressed air engines over internal combustion engines is their lower manufacturing cost. Because compressed air engines operate at far lower pressures than gasoline or diesel engines, building them requires less strong and hardened steel or aluminum. This makes larger-scale production more economically feasible and environmentally beneficial. And although the differences may not be as significant as those seen in EVs, they exist nevertheless. Also, it goes without saying that compressed air engines have the lowest operating expenses. Compressed air is much less expensive than gasoline or electricity, and it's considerably much simpler to get. Not to mention that these engines will be completely future-proof because they produce no waste. They only use pressurized air that retains its structural integrity after leaving the chamber. However, as powerful as they seem, compressed air engines have a few limitations that prevent them from being developed and deployed on a larger scale. The first issue is that compressed air engines have extremely low power. Pressurized air has a relatively low energy density, thus reducing its power. Furthermore, because they have light components and do not produce high amounts of pressure, the torque of such engines is extremely low, making them far less useful in the real world. Additionally, because the engine is entirely mechanical, it must run at a high RPM, which causes excessive component wear. And since the engine does not use liquid as its primary propellant, putting lubricants into the engine is more difficult than with internal combustion engines. The most serious difficulty with compressed air engines is their severe inefficiency. And despite the fact that compressed air is almost free, this could not be more wrong. The majority of prototype compressed air vehicles that have been created have a range of less than 100 miles. This means that you'd have to refill it on a regular basis and would not be able to go on long journeys. Lastly, let's consider the matter of safety. Since there was no better alternative, the majority of prototypes made use of standard steel air tanks to store pressurized air. This meant that the automobile, which was already gutless, would be much less powerful owing to added weight, as well as more prone to explosions if the tanks were destroyed, since you were sitting on a pile of compressed gas. That being said, GM has worked exceptionally hard to eliminate the flaws in this technology, and they've proven pretty successful. First and foremost, the issue of the car's power has been resolved with the installation of new high-pressure air tanks. These high-pressure tanks compress the air even further, resulting in increased cylinder pressure. As a consequence, GM's new compressed air prototype has performance statistics that are about equal to conventional gasoline engines. Yup, the torque might not be top-notch, but hey, they still pack enough punch for your everyday ride. Furthermore, GM has also developed a technique to increase the vehicle's range. But how? Well, by turning the vehicle's chassis into one large compressed air reservoir. However, this requires the vehicle to be specifically developed with compressed air engines in mind. This includes particular reinforcements and even the use of composite materials, like fiber-reinforced thermoplastics. This enables the vehicle to remain very lightweight while also being significantly safer than utilizing standard high-pressure tanks, since crashing and rupturing the reservoir would never result in an explosion. Now, you may ask, when will this technology be implemented? The answer to the question is really challenging. However, there's a strong likelihood that these engines may reach mass production within the next several years. This is because, as can be concluded, GM has made a significant investment in making this engine a reality. They continue to investigate and create answers to many current difficulties, and they're very committed to delivering a genuinely wonderful product that will completely transform the automotive industry. Furthermore, the overall mechanical familiarity and closeness to internal combustion engines enables GM to design such engines considerably quicker than if they were starting from scratch. However, it would be naive to suppose that GM is doing this out of the kindness of its heart, since it's not. GM recognizes all too well that the days of internal combustion engines are coming to an end, and they still don't have a foothold in the EV market. As a result, GM is looking for a way to create a new market of vehicles that would allow them to dominate other car manufacturers while also making obsolete both internal combustion and EVs to further secure their hypothetical position as the leader of the new automotive age. However, as amazing as this sounds, it's not the first time a major manufacturer has attempted to incorporate pressurized air into automobiles. As we told you before, Peugeot produced a hybrid version of their Peugeot 2008 crossover around 10 years ago. But instead of employing electricity, this vehicle combined an internal combustion engine with compressed air. The end product was a powertrain that combined the power and torque of an internal combustion engine with the environmental benefits of compressed air engines. The engine was able to reach an impressive 120 miles per gallon. But unfortunately, Peugeot quietly abandoned this concept shortly after it was created. There were no justifications offered other than Peugeot stating that the idea was not profitable enough, which makes little sense. So, what's the reason behind its abandonment? It's anyone's guess. However, we feel it's related to huge oil firms. since such an engine developed and manufactured on a massive scale might possibly drive them out of business. While this may seem far-fetched to some, oil firms have done similar things in the past. In the mid-90s, Stanley Allen Meyer created the water fuel cell, a groundbreaking invention that had the potential to power cars using only water. Once Meyer made his invention public, he faced relentless pressure from major oil companies to abandon his work on the water engine and admit that it was a scam. Meyer kept going in his battle against the oil giants, all the while seeking a company willing to invest in the advancement of his water fuel cell. On March 20, 1998, Meyer and his brother attended a dinner with two Belgian investors. At one point, Meyer dramatically left the restaurant, loudly accusing the two businessmen of poisoning him. He unfortunately passed away just moments later on the sidewalk outside the restaurant, with his brother by his side. And if that sounds bizarre, what's even more peculiar is that both the vehicle he was working on and a couple of prototypes of this water fuel cell disappeared mysteriously from his home garage shortly after his passing. Well, it seems like this whole situation is just a crazy series of unexpected twists and turns. However, it's quite clear that oil companies prioritize their profits over the well-being of the environment, which is rather unfortunate. Therefore, GM, if you're listening, please continue working on the engine in complete secrecy. Otherwise, it could end up like Peugeot's hybrid, or even worse, like Stanley Allen Meyer. And if you enjoyed this video, watch this next video about GM possibly going bankrupt because of their addiction to controlling the car industry.